Neural networks are a fascinating area of artificial intelligence, mimicking the way human brains process information. They are composed of interconnected neurons, which work together to recognize patterns and make decisions. Let's explore the structure and function of these networks. A basic neural network consists of three main types of layers. The input layer is where the network receives data. Each neuron in this layer represents a feature of the input data, such as pixel values in an image or words in a sentence. Hidden layers perform transformations on the input data. A network can have one or multiple hidden layers, and the more layers there are, the more complex patterns the network can learn. Each hidden neuron combines inputs from the previous layer using weighted connections and applies an activation function to introduce nonlinearity. Finally, the output layer produces the final prediction or classification. The number of neurons in this layer depends on the task, such as one neuron for binary classification or multiple neurons for multi-class classification. Activation functions are crucial in neural networks, introducing nonlinearity to help the network learn complex patterns. Common activation functions include the rectified linear unit, or ReLU, which is efficient and widely used, the sigmoid function, which maps values between 0 and 1, and softmax, which is often used in the output layer for multi-class classification tasks. Neural networks learn by adjusting the weights of connections between neurons based on the data they process and the errors in their predictions. This process is known as backpropagation, where the network minimizes the difference between predicted and actual outputs using a loss function. During training, the network iteratively updates these weights to improve accuracy. The learning rate determines how much the weights are adjusted during each iteration. A well-tuned learning rate ensures the network converges to an optimal solution efficiently. By refining these weights, neural networks become adept at recognizing patterns and making accurate predictions.